Hello and welcome to Unit 7. Unit 7 is going to cover chapters 11 and 12 and we're going to talk about force and motion. So let's go ahead and get started with our first video and our first set of notes. Now, when you're looking and you're watching motion, when an object changes position with respect to a frame of reference, the object is in motion. So if I'm at my table, my lab table up front in my classroom, that could be the frame of reference. And if I go from the back of the table to the front of the table, I've changed position in respect to that frame of reference, so I was in motion. Now, distance measures the path taken. So if I walk from my desk to the door in our classroom, then we would measure that, and that would be the distance for the path that I had taken. And a last little definition that we're going to look at is displacement. Displacement is the change of an object's position. So when I move from the back of my lab table to the front of my lab table, I've been displaced. One way that I remember that, this is a very sad illustration to use, but it does help you remember what displacement is. A lot of times when there's a hurricane or a tornado or a natural disaster, and people have to leave their homes to go to a new town for a little bit while they rebuild, a lot of times they will say those people are displaced because they're not in the homes that they want to be in. They're in temporary housing or a temporary city. And so that's how I remember displacement. So it's when something changes position. Now let's look at speed and velocity. Speed tells us how fast an object moves. Velocity tells us the speed at which something moves and the direction that the object moves in. So for example, the speed, if I'm traveling to my parents' house in Blue Ridge, Georgia, my speed would be 70 miles per hour. My velocity would be 70 miles per hour north on 85 or on 75, right? Because velocity tells you and includes the direction you're going. Now, the formula for speed is speed equals distance divided by time. We use v to represent speed because speed and velocity are always the same number. Just remember that velocity has direction with it. And then we use distance for time, d for distance and t for time. Now, the SI unit for speed is meters per second, so it's m/s. So anytime that we're listing velocity or speed, we want to make sure that it's listed in meters per second. That's going to be what we use the majority of the time. Every once in a while in science we'll use miles per hour, but not very often. It's going to be meters per second mostly. Now what we're going to do is we're going to go and do some of our practice problems in our notes and also draw the circle that we can use to help us rearrange this equation. Okay, if our formula is v equals d over t, then let's remember the circle that we used, because this formula shows us how to solve for velocity or speed. But what if they asked me to solve for distance or time? I would have to rearrange my equation. So let's use our circle to do that because it makes life much more simple. Now, d over t are over one another in the formula, so they have to be over one another in the circle. Now, you could have put t here also if you wanted to, but just make sure d is over t. Then you can use the empty space to put the remaining variable. All right? Now, if you'll remember, we cover up the one that we need to calculate. So if I'm covering up v with my finger, that tells me d over t is the formula. If I'm covering up d with my finger, that means telling me that velocity times time is the formula. If I'm covering up t with my finger, then that tells me that distance divided by velocity is the formula. Okay? So you cover up on the circle whichever one you're trying to calculate for. Now, let's look at number 1 example in your notes. Calculate the speed of a dog running through a field. What is his speed if he is covering 23.7 meters in 54 seconds? Now, you'll remember when we calculated density that we have to do several steps to get credit for any kind of mathematical work we do. So the first step is to write down our variables so that then we can put if we know them or not. So we have v equals d equals t equals. And it says, calculate the speed of a dog running through a field. What is his speed? Since it says what is his speed, we can automatically know that's what they're asking us to find, so we don't know V yet. And it says he is covering 23.7 meters. We know that 23.7 meters is a distance measurement, so we can put meters down there. Then 54 seconds, seconds is a time unit, so we can go ahead and fill in our time. Now, to solve, you always put the one with the variable with the question mark down first. So V equals, and we can look up at our circle to know that it's D over T. So we put our formula in letters, and then we fill out our formula with the numbers. D equals 23.7 meters, and T equals 54 seconds. And so this is what you can then put in your calculator to calculate your answer. So in this question, V equals 0.44 meters per second. And if you look, M right here and S right here, M divided by S, that's why our units are M/S, because it's M divided by S, meters per second. Now, this is what I would like you to do. I would like you to go ahead and do number 2, number 3, and number 4. So pause the video, do those, and then come back so that you can see the answers. All right, let's look at example number 2. I know it doesn't say 2 right here, I'm sorry. But this should be example number 2. If a cross-country runner covers a distance of 347 meters in 134 seconds, what is her speed? The first thing we do is we write down every variable. And it says down here, what is her speed? So that means we don't know speed. That's a question mark. The distance is always meters. And one little trick that you can do is you can underline numbers in the formula, in the question. That sometimes can help you see what you are already given. And I started writing this wrong. So let's see. Distance is 347 meters. Time is 134 seconds. Let's write our formula in letters. We're looking for V, so we say V equals D over T. And then we fill them in with numbers. 347 meters divided by 134 seconds. And then we calculate. We say 347 in your calculator divided by 134. And we can say that our answer is 2.59 meters per second. And this is our answer. Now let's look at question number 3 in your practice. And we want to write our formula again in our circle. And remember, I'll give you the formulas for the test, but I do not give you the circles. So you have to remember how to make the circles. Now, which object has a greater speed? A ball rolling down a 3.4 meter hill in 6 seconds, or a fish swimming upstream and covering 5.4 meters in 24 seconds? We immediately know when it asks you to compare two things, you're going to have 2 problems. So let's go ahead and do ball rolling over here. And let's do our V equals, D equals, T equals. And it says a ball rolling 3.4 meters in 6 seconds. And so we're obviously looking for the speed. And let's go ahead and calculate that. V equals D over T. Fill in our numbers. 3.4 meters divided by 6 seconds. And once you put that in your calculator, you're going to realize that the speed of the ball rolling is 0.57 meters per second. Now let's go ahead and calculate the fish. Fish is V equals, D equals, T equals. And it says the fish swimming upstream and covering 5.4 meters in 24 seconds. And so we're looking for the speed. V equals D over T. Fill in our numbers. 5.4 meters for distance divided by 24 seconds for time. And when you put that in your calculator, you're going to say 5.4 divided by 24. And that's going to give you 0.23 meters per second. So which one of these is moving faster? The one moving the fastest is the ball because it's moving 0.57 meters per second, and the fish is only swimming 0.23 meters per second. So the ball has the greater speed. Now let's look at our last practice problem. Again, this is not practice problem 1. It's just when I copied and pasted it, it did weird numbers and I forgot to change them. So let's go ahead and write our formula again. V equals D over T. And our circle. Which if we're doing a worksheet, you can have this at the top and you won't have to continually rewrite it. All right, if a cyclist in the Tour de France traveled southwest a distance of 12,250 meters in 1 hour, what would the velocity of the cyclist be? So say V equals D equals T equals, and it asks us down there what would the velocity be, so we know that's the question mark. The distance, let's underline our numbers. Okay, the distance is 12,250 meters, and the time is 1 hour. Now this is different. You can place this into seconds if you would like to, but we don't do it in our class. You don't have to know how to do that in our class at this moment. So let's go ahead and set up our letter equation. It's V equals D over T, and let's fill it in with our numbers. And once you put that in your calculator, it's 12,250 divided by 1. So that means your speed is going to be 12,250 meters per hour. Okay? And if you wanted that in seconds, remember, you would just convert the hour to seconds if they asked you to do that. So this is going to be the velocity of our cyclist. Now, real quick before you leave, if I gave you the time, but I'm looking for the time, like if somebody said that they needed to know the time, what would our formula be? Look at the circle, cover up time. If you need time, it's going to be D over V. If you're looking for distance, and this is just a review of what we did earlier, you would cover the D up on the circle, and then it would give you your equation of V times T. I just need to make sure that you're familiar with those. We'll do more of this type of practice in class. Now, for your summary, this is what I'd like you to do. I'd like you to take the letters G, L, and R, G, L, and R, and tell me 3 things that you've learned that correspond to those letters. I hope you have a great evening, and I'll see you in class.